All right, welcome back to Dilemma's Concepts. What we're going to be looking at today is adding matrices as well as subtracting matrices, and we'll be looking at scalar multiplication with matrices. Stay tuned. I will be right back after this message. Looking at now is adding matrices. So let us say that we have question 1 that says we want to add A plus B. Remember though that A refers to this matrix here and B refers to this matrix. One of the things that you have to pay attention to is you cannot add matrices of two different orders. So this is a 2 by 2 matrix here. That's A, and the B matrix is also a 2 by 2 matrix. Because they are of the same order, it simply means that we can add them. So let us set up what we have. Now, the reason why we can only add or subtract matrix of the same order is that we're adding corresponding spots. For example, number 2 will be added to -1. Number 3 will be added to 2. Number 4 will be added to the 0. And number 5 will be added to 6. So as you could see, based on the color coding that I have, we're putting together we're going to be adding the matrices, or the elements rather, that are occupying the same position. For example, 2 will be added to -1, and then 3 will be added to 2, 4 will be added to 0, and 5 will be added to 6. All right, let's finalize. 2 plus -1 is 1. 3 plus 2 is 5. 4 plus 0 is 4. 5 plus 6 is 11. So when we add matrix A plus matrix B, the result is as follows. 1, 5, 4, 11. All right, let's look at what if we wanted to add all right, say we wanted to add C plus D. C plus D. All right, so what we want to do quickly is to have the matrix C. So C is 0, -1, 2, 1, 4, 7. This is the matrix C. We want to add that to the matrix D, and the matrix D is -2, 3, 0, 9, 2, 1. Remember that we can only add or subtract elements that are actually in the corresponding position, which means that we're looking for matrices that are of the same order. So this is a 3 by 2 matrix. This one is a 3 by 2 matrix as well. So yes, it qualifies those criteria for them to be added. Remember, we're adding elements in the corresponding spots, which means that 0 will be added to the 2, -1 will be added to the 3, 2 here will be added to the 0, 1 will be added to the 9, 4 will be added to the 2, and the 7 with the 1. Let's put those together. We're looking at 0 plus -2, and -1 plus 3, 2 plus 0, 1 plus 9, lastly 4 plus 2, and 7 plus 1. So there it is. We're adding the elements that are in the corresponding spot. 0 plus -2, -2, +2, 2, 6, 8. So this is the result of adding matrix C plus matrix D. All right, what if we want to subtract some matrix? Simply need to represent matrix A, which is 2, 3, 4, 5. I want to subtract matrix B, which is negative 1, 2, 0, 6. Remember that we only can subtract elements that are in the corresponding position. So definitely, let's double check to see if these matrices are of the same order. This is a 2 by 2 matrix, and matrix B is also a 2 by 2 matrix. It simply means that we have elements in corresponding spots, so we're able to do this. Let's just highlight what we're about to put together. We're about to have 2 minus negative 1, then 3 minus 2, then 4 minus 0, and finally 5 minus 6. So let us come through with this. 2 minus negative 1, 3 minus 2, 4 minus 0, 5 minus 6. After this, the rest is to put these together. Bear in mind that when two negatives are beside each other without any number between them, it becomes a plus. So that is 2 plus 1, that's 3. 3 minus 2 is 1. 4 minus 0 is 4. And 5 minus 6 is minus 1. This is the result of A minus B. All right, so in scalar multiplication, let us consider, we will consider A times B, C, D, E. Now, basically, in scalar multiplication, anything that is directly outside the matrix will be used to be multiplied by everything inside. For example, the A will multiply with the B, the A will multiply with the C, the A will multiply with the D, and the same A will multiply with the E. As a result of that, we're looking at AB, AC, AD, and AE. So pretty much, when you look at the final result, we're seeing that A actually distributes itself by multiplication to every element that was in that matrix. So that's just the idea. What if we have a number outside? For example, 3, and we have the matrix negative 1, 2. The final result of this is that we'll have 3 times negative 1, 2. So we'll have 3 times negative 1, 3 times 2. Finally, negative 3, positive 6. That is 3 times that matrix. So with scalar multiplication, all we're doing is we're multiplying anything outside by every single thing on the inside. It doesn't matter if it's a fraction. For example, a half. And then in this matrix, we have 3, 4. Basically, what we're going to have is that negative a half will be multiplied to the 3. Negative a half will multiply to the 4. Let's finalize this. This becomes negative 3 halves. This we could cancel here. 2 into itself 1 time, 2 into this 2. We end up with negative 2. So the final response would have been negative 3 halves minus 2. So basically then in scalar multiplication, we're applying anything that is directly outside, and it will be multiplied by all the elements that are actually inside the matrix. See you next time. Bye-bye.